Hello everyone, and welcome to Data Science for Social Sciences. In this video, I'm going to be talking a little bit about what data and data science are, and then I'll go over what you can expect from this course. So what is data science? Well, let's start with what data is. Well, data are observations about the world, and so this can come from many sources. One is surveys, where people kind of go out and actively collect that data. One example is the General Social Survey. Another source is administrative records, and this can be from stuff like birth certificates, tax records. These data are collected for another purpose, not specifically for data analysis, but they can also be used for data analysis. And another source is social media, stuff like Facebook, Twitter. These are modern, data sources, and these can provide lots of insights. But there's a lot of data out there just because of the internet, because of computers, how powerful they are now, and so there's so much data out there, and new methods are being developed in order to analyze that data. So, what is data science then? Well, one definition that you might use is that data science is the study of making conclusions about the world based on our understanding of the properties of data. Just, like you have stuff like chemistry where you're looking at the properties of chemicals and you're trying to understand more about the world in that sense. We can think about data science as, we're looking at the properties of the data, we're using the properties of the data in order to make conclusions about the world. Right, so why data science? Why are we doing all of this? Well, so we want to be able to make better decisions and make conclusions about the world. So for the General Social Survey, we might want to monitor societal change in the U.S. For administrative records, we want to keep track of essential information and maybe use that to make conclusions about the people the administrative data are about. And then for like the social media data, we might be able to use those to see how certain tweets, certain posts affect social perception. So one example of how data science is used is in this, where we have this race for the House. This is the 2018 midterm elections, and this is the data analysis that 538 does. This is a very popular political statistical analysis website, and they have all of these data from polls. And they're using it to kind of forecast in order to predict what's going to happen. And so, it has all these different probabilities. It has kind of like an average of what Democratic seats might be gained, stuff like that. And so basically, this is just kind of one application of how we might use data science in order to kind of predict what's going to happen. But we do have to be careful. And so there's a lot of data out there, but there's a lot of pitfalls that you might fall into when trying to interpret that data and trying to analyze that data. And so this is kind of a silly example right here, but I like it because it kind of shows what I'm trying to say when talking about all of these pitfalls. And so basically this is the number of people who drowned by falling into a pool, along with the number of films that Nick Cage appeared in. And so you can kind of follow along these red and black lines, and it seems like they actually correlate pretty closely. So in years where Nick Cage appeared in more films, more people drowned by falling into a pool. Now, obviously, there's no connection there. There's no, causation. It's not like Nick Cage is forcing people to drown in a pool by appearing in movies. But there's correlation, and there's going to be a lot of cases in which you find correlation and there's no sort of causation, but it seems like there is just because there is that correlation. So you do have to be careful when you're analyzing data about making conclusions that aren't correct, just such as this case. And they won't be as obvious as this case. This is very clearly not a causal relationship, but you might fall into the trap of making these kinds of very strong statements when you're doing data analysis. So what are the goals of the course? To kind of put it succinctly, it's to kind of avoid the situations of trying to say, Nick Cage movies cause people drowning in pools. Kind of holistically, what we're going to try to do is develop your ability to recognize and understand opportunities, to use data analytics to enhance decision making. And along with that is to reinforce proper statistical intuition and be able to critically evaluate statistical studies, particularly within the social sciences context. What we'll kind of go over as part of the course is how, for social sciences, there's different types of data, there's different data sources. And so you might have to kind of analyze and look at the data within these different contexts differently. And then lastly, be comfortable with using Python to implement data analysis techniques. I don't expect you to be, complete masters of Python by the end of this course, but you should understand how it's done. You should understand the process that, is involved in, taking the data, analyzing the data, and making conclusions. All right, so to finish up, I'll kind of talk a little bit about this data analytics workflow that I just kind of briefly alluded to right now. So first, what we do is we identify the question and define the population. And identifying the question, that might seem like a trivial thing, but in fact, it's very important. This is a step that a lot of people kind of skip or gloss over. And it's very important to kind of start with the question. What are you trying to figure out? Why are you analyzing the data? Otherwise, it's very easy to fall in the trap of just kind of finding whatever correlations are there and making conclusions based on that. Next, what we're going to do is collect the data. And so this can, as I said, come from many different sources. And there's all these questions about how we're going to do this. And then next, we're going to use that data to make conclusions. Again, there's just kind of all of these caveats, all of these questions that we need to ask when we're doing this. Stuff like what are the trends in the population? What are two groups significantly different? It's all going to depend on how the data collection was done and what kinds of conclusions we can make based on that. And then lastly, we're going to evaluate the conclusions, kind of think about all of these different caveats that we just talked about. How confident are we? What is our margin of error? In that 538 graphic that I just showed, there were just kind of these percentages, just probabilities of certain events happening. And so whenever you have anything within a statistical analysis context, you're going to have a uncertainty measure associated with it. So this could be like a margin of error, this can be kind of a level of confidence, that kind of thing.